Hey, Kylie. Ooh, we got a whole bunch of people here. Bunches and bunches of people. Hi, Kylie.
Hi.
Okay, good. I can hear you. You can hear me, I take it?
Yes.
That's not always a given. Oh, okay. How's this treating you? Kylie, are you a SBC student?
I'm about to graduate from high school. I'm still in high school, but
Good for you.
I'm going to UF in the fall, but I just wanted to take some classes this summer for my major.
Good for you. Has this been an easy transition?
It's all right. I still have a lot going on, but yeah, pretty easy.
Don't let it overwhelm you, okay?
Okay.
Do I have you for lecture or not?
No.
Okay, good enough. Everybody else, I'm sorry, I just asked Kylie a general question. Are you having a transition okay? Everything's okay? Safety quiz, you got the safety quiz and the syllabus done? All right, did you look at the syllabus quiz? Did you get a bad result? Actually, I'm sorry. No, let me back up on that. I'm sorry. I haven't even looked at it. I haven't even graded it yet. So I'm sorry, that's on me. Just a reminder, you have as many opportunities to do the syllabus quiz as it takes. I may ask you for 5 points extra credit. I may ask you guys to upload something into a chat room so that if you're able to upload a picture, you can explain it to others. And I may give you I'm going to give you 5 extra points if you take the time to describe how you were able to upload a picture successfully. Okay? But you only get the points if you got 100% on the syllabus quiz. No. You only get the points if you uploaded the picture correctly. You have as many opportunities to take the syllabus quiz to get 100% as you need. Okay, everybody understand that? I will give you unlimited opportunity, and I will put the end date a week before the final because I need to get grades straightened up at that point. Are there any questions about that, guys? So if you
Professor, I do have a question. I missed the last class due to a situation with my classes and financial aid. So do I still have the time to do the quiz and the test? I mean the quiz and the syllabus submission.
Yeah, I'll let you do it, Gabe.
All right, thank you.
It's for the most part, it's automatically graded, so it's an inconsequential thing. Plus things like you had the first part of the semester, I let you do the first lab or two late. Don't abuse that that nice thing I'm doing. Okay. So yes, Gaith, I will let you open it. Okay.
Awesome, thank you.
Anything else, ladies and gentlemen? Gaith, I have uploaded the recording on Mondays. I'm sorry, wrong. You're in the face-to-face lecture too, Gaith, right?
No, Professor, I'm only for your lab.
Okay. Who do you have for lecture?
Stodum, I think. Stodum. Cliff. I don't know his first name.
Okay. You didn't like me, huh?
No, I did. I didn't have.
All right, I'm going to penalize you, Gaith. Guys, you have to understand. I had Gaith for introduction, and we've developed a relationship. Do you want a visual, Gaith? Do you want a visual?
Yes,
Okay, I'm just trying to tap dance to make sure. I got 23 people in. That seems like most everybody. Now, the thing about it is, I need to see your faces. Marvina, put your visual on. Put your camera on. Gaith?
Oh yes, sir. I'm getting the visuals. Just give me about a minute. Getting my
Thank you very
espresso.
much. Paige, where are you at? Actually, your lighting's very bad, Paige. Okay, thank you all. All right, now, I'm not going to bother showing screen. Okay, obviously Gaith is here. Corey, did you manage to make it?
I did indeed. I'm right here.
Okay, you understand what, guys, Corey was concerned because I didn't send the invitation out.
I was
We-
freaking out like 5 minutes ago. How do I
I-
get in? How do I get in?
I'm sorry about that. It's just my own personal opinion. Literally speaking, I have people give me information all the time. What happens is I write it down, put it somewhere, and then when I really need the information, it's not there. So I basically
understand.
tell people, don't give it to me until I need it. And
understand.
that's worked out in probably about 10 of my last 63 years. So you will get an invitation, but it will be coming at the last minute, just like it did today. Jeremiah, you here?
Yes, sir. I'm here.
Jonathan? Jonathan Roa.
Hello.
Okay, thank you.
All right.
Sorry. Andrew?
Here.
Andrew, did I have you before?
Yeah, with that story you told last summer.
What story I told last summer? I told a lot of
sir-
stories.
The one where you had to ask a student to turn his camera off.
Ah, okay,
Yeah.
good
Yeah.
enough.
I changed my major and I didn't need chem lab before, but now I need chem lab, so I'm just
God bless it, right?
yeah.
You gotta love college administrators.
Yeah.
Elaine.
Here.
All right, Kyle.
Here.
Mervina, yes, I know you're here because you weren't. Are you pictured up now, Mervina?
Yeah.
Natalie.
I'm here.
Alaya,
Here.
did I say it correctly?
It's Aaliyah.
Okay, I gotta phonetically mark it. Alexis.
I'm here.
All right, Taylor.
Here.
Oh, I wasn't expecting a female voice. Marlene. Marlene. Marlene Hannah. Abhishek. Abhishek, did I do that? Okay.
Yeah.
Geddes. Geddes.
Here.
Okay. How about me? Did I butcher that?
Yeah, you were pretty close.
What is it?
Garrus.
Gare. Okay. All right. Bethany.
I'm here.
Did I say that correctly?
Yes, sir.
Larry.
Here.
Christine.
Here.
Paige.
Here.
Yeah, I know you're here because you had the dark background. Maria.
Here.
All the brain cells haven't gone yet. Adrienne.
Here.
And I do remember you asked me to call you something. Was it T?
Here.
Is that what I'm supposed to be calling you?
Yes.
Kylie?
Here.
All right. All right, guys. It's important that you take notes for this because your observations that you're doing in this lab are going to be directly applicable to the final. I didn't realize that when I taught this. I taught this course online for the first time in the spring. And I didn't realize that they based the final on your observations that you wrote. So guys, you're going to need to keep the notebook. You're going to need to put the observations for this lab in the notebook so that you can access them in the final. Is that clear? Come on, somebody else.
Yes, sir.
Thank you so much. All right. I am going to share my screen right now. Generally speaking, I try and talk for about a half an hour. I literally go through a little bit of the theory behind the experiment, and I try and get through the procedures and everything you need to do to get the experiment an understanding of what you're supposed to be doing hands-on. Then what I do is I go through the actual quizzes to make sure that you understand what's going on with the results and the post lab. Now, if we look, he has a very nice description for this particular experiment on how you're supposed to do it. Okay. If you look, when you call up chemical and physical changes in properties, he has what you're supposed to be doing for it. Now, if you had introduction, I know that you've had single replacement reactions and double replacement reactions. He gives you a video on double replacement reactions here. I don't know why he didn't bother to do one on single replacement. What I may do, and I just thought about it, I may put up my PowerPoint for chem reactions from my intro lecture. I may put that in here. That may help you out to understand that a little more. But you are supposed to watch the video, and actually we are going to watch the video today. I am going to make you watch the video because I've got something else that I've got that's going to help you. So any questions about what we're doing, basically the facets of the class? Thank you for shaking your head, Kylie. Okay, I'm going to stop share here and we're going to go through my PowerPoint. This
I just
is
one question, Mr. Popovich.
sure.
For the lab books, would we submit them? Pen, pencil, do you care?
How am I going to tell?
Gotcha. I just wanted to see.
To be honest with you, get used to doing them in pen. All right. If you make an error, the proper way in a notebook is to make one line through the error and put your initials on it. Don't try and erase things. Literally speaking, my laboratory notebook, when I was working as a synthetic chemist, my notebook got subpoenaed. And what they don't want, it was involved in a patent fight. And what they don't want is they don't want torn out pages from a notebook. They don't want erasures because it looks like you were trying to hide something. Does that make sense, guys? So, evidence of a chemical change. Understand this. All right. We're dealing with two different things. We're dealing with physical and we're dealing with chemical. When we are dealing with physical, the chemical itself, the substance itself is not changing. When we are doing with chemical, the actual substance is changing. Physical involves superficial things like how it looks. You can take a piece of paper, crumple it up. You can take that piece of paper, tear it in two. You can take water, freeze it, It's still water. It just is in a different state. You can take water and boil it. Same chemical, just a different state. On the other hand, if we take that water and we put an electrical current through it, what will happen is it will decompose into hydrogen and oxygen. I started with water. I now have hydrogen and oxygen. That is chemical. So that's the basic difference between chemical and physical. In chemical, you change the actual substance. In physical, the compound remains the same. Compound or element remains the same. Now, the difference between property and change is semantics in the way it's generally worded. Property is what it is. It hasn't happened. The action has not happened yet. Iron can rust. Has the action happened yet? Somebody answer.
No.
No.
The action hasn't happened yet, so it's a property. My iron skillet was rusting in the sink. Is it happening?
Yes.
Yes.
So
Yes.
if it's happening, that is a change. Paper can be torn. Property. I tore the paper. Change. So are you kind of understanding how you got to really look at the question that's offered to you to determine whether or not you've got a change or whether you've got a property? Are we good with that concept?
Yes.
Okay. Now, if I am dealing with a, well, where was I going with that? Never mind. When I am looking at a chemical change, I've changed the substance, haven't I? That's the
Yes.
definition of a chemical change, right? You've changed the substance. Now, if you change the substance, what are the chances the physical properties are going to be the same? If you get a change in the physical properties, isn't it very likely you've changed the substance?
Yes.
If you've changed the substance, you've undergone a chemical change. Now, physical change is basically doing a superficial change of the appearance, or it's changing the state, going from a solid to a liquid to a gas, gas to a liquid to a solid. That is just physical. The other thing is, if you were dissolving something, if you're dissolving something into another substance, you can literally take that other substance away and you're left with the original substance you put into it. If you put a solute into a solvent, evaporate all the solvent away, you still have the solute. You haven't changed anything. It is still a physical. So the act of dissolving it is a change, but it is a physical change, not a chemical change. So if we've undergone a chemical change, we got a new substance, more than likely we have new physical properties. If you take copper chloride, which is composed of blue crystals, and you dissolve it in clear water, the solution turns blue. Is that really a change of color? What's making the blue color in the solution?
The blue from the copper.
So we haven't really changed the physical property. So that is a physical change. Does that kind of make sense, guys?
Yes.
On the other hand, if I take a clear solution of potassium thiocyanate and I mix that with a very, very pale yellow colored iron 3 nitrate, if I mix those two together, I get a blood red color. Is this a chemical change?
Yes.
I've got a new property. The new property is a new color. This is a new physical property of the substance I've created. So therefore, I have a chemical change. All right, I have cobalt-3 compounds. By definition, they're red crystals. So if you dissolve them in water, you get a red solution. So copper-3 ions in solution, you get a red solution. I put copper metal into a clear colorless solution. After 20 minutes, the solution has a noticeable pink color. Did a reaction take place?
You said you were starting with regular copper, not an ion.
I am starting with regular copper
Yes, so a reaction did take place.
because originally the water was clear. I have knowledge that copper-3 ion makes a red solution. So I have changed the copper metal into the ionic form. I'm sorry, the cobalt metal into the ionic form of cobalt. What's the Statue of Liberty made of? Anybody?
Copper.
Copper.
Okay, what color is this? What color is copper?
Bronze.
Copper
Okay, I'll give you bronze. It's kind of a cheap shot because bronze is made of copper, but I'll give it to you. Kind of a brownish color, right, guys?
Yes.
I know it's early in the morning, but I got to have a designated yes man and a
Yes.
designated no man. All right.
Yes.
All right. So, what color is the Statue of Liberty?
Green.
So, if the Statue of Liberty is made of copper and copper is brown and now it's green, do we have a chemical reaction?
Yes.
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 You heat up magnesium. Magnesium, a bright, shiny metal. After you put this into the Bunsen burner, you notice the very edges of the metal, you have a very fine white powder. Do we have a change in the physical properties?
Yes, we do.
Do we have a chemical change?
Yes.
How many of you have done the volcano experiment? Actually, I think you're going to see it in this upcoming lecture. How many of you have done the volcano experiment? You put vinegar and baking soda together and you watch it go crazy. I can't believe there are 23 individuals out there that have scientific intent that have never done the volcano. I mean, for God's sake.
I did that one a few times as a kid.
Yeah. You did
Yeah,
it to
Professor,
irritate your
can we get a
parents, right?
visual?
You did it to irritate your parents, right?
Sure.
And then you had to clean up all this mess. All right, you've got baking soda, a solid. You've got vinegar, that's a liquid. You put them together, you get this gas. More importantly, you take a splint and you light it. You put the vinegar in on the baking soda. You put the acetic acid in on the sodium bicarbonate. Everything puffs up, the gases puff up, it foams up, then it dies down. Then what you do is you take a lit splint, put it in on the air above the liquid, it goes out. Can anybody give me an idea of what the gas that produced was?
Carbon dioxide.
What happens is you created so much pressure of carbon dioxide, it drove out all the oxygen, so that when you put the splint in there was no oxygen. It goes out. Chemical reaction or not? Yes, man.
Yes, it is a chemical reaction.
You're missing your cue. Another reaction. I have hydrogen peroxide. It's a clear liquid. I add some potassium iodide. Again, everything foams up. Has anybody ever seen the elephant toothpaste experiment?
Yes.
Yes.
What they do is they put a little bit of dye in it, and this thing literally goes crazy. A little bit of dye and a little bit of soap. But that's basically what we're talking about. So when I do this, it foams up, it goes down. Now, if I light a splint, shake it off so that I put it out, it's still got an ember in there, and I put that in on the atmosphere above the liquid, it reignites. What gas do you think we have?
Oxygen?
We have oxygen because we've got an oxygen enriched environment. Do we have a chemical reaction?
Yes.
Okay. I
Can we
got
get a visual?
You will get a visual in a second, Gaith. You have a clear yellow liquid of lead nitrate. You add that to sodium chloride. Clear liquid, no solid in it. You add it to a clear solution, no solid. Put them together, you get a precipitate. Do we have a change in the chemical properties?
Yes.
Before, everything dissolved in water. Now we got something that doesn't. That is a change in a chemical property. Therefore, we have a chemical change. Beware. Beware when you're interpreting hot and cold, because the process of dissolving something can change the temperature. Has anybody ever broken a bone or something? You go to the hospital, the nurse grabs that plastic pack, smacks it, and then puts it on your afflicted area. Has that happened to anybody?
Yes.
What's happening in that pack? You have a whole bunch of solid material in one section of it, a whole section of water in the other. When she smacks that bag together, she breaks the seal between the two, and you get a dissolution happening. Just the act of dissolving the salt in the water lowers the temperature of the water. And that's what makes it cold. By the same token, is anybody a hunter?
I've been
Class of
hunting.
23 with more than one male, and I don't have a hunter?
Well, it depends on the hunting. What are we hunting for?
Not your lost
Uh.
objects, Gaith. In any case, there are hot packs. If you go to what is the ROA or some sort of camping place, you can buy these
REI.
hot packs. You can smack them together, and literally speaking, it gets warmer. Sometimes heat can be a sign of a chemical reaction. Sometimes it's just a sign of the substance dissolving. All right. Now we're going to go through a little bit of chem reactions, guys. I got magnesium and HCl. I'm gonna have to go to the slideshow because it doesn't make sense unless I go to the slideshow. Magnesium and HCl, guys, what kind of compounds are there? What kind, I'm sorry, excuse me, what kind of substances are they?
Magnesium is a metal,
Metal?
and HCl, that's hydrochloric acid, right?
Sorry about that. Magnesium's a metal. HCl is an acid, or it's also an ionic
liquid?
solution.
Oh, okay.
All right. What you have to do when you have reactants, you have to identify what the type of reaction that could possibly take place is. I've got a metal, an element, and I have an ionic compound. Anybody know off the top of your head, what kind of reaction am I dealing with?
Single displacement.
Single displacement. In a single displacement reaction, what happens? Oh dear God, he's asking me questions from intro.
The well, the elements would switch. Is
What's
like
the
a very
product?
basic
What's the
Um,
product?
magnesium chloride.
The magnesium replaces the cation in the ionic species. When I have a single replacement, that's what happens. The magnesium replaces the cation in the ionic substance. If the magnesium is more active than the cation. If the neutral element is less active than the ionic cation, no reaction will take place. All right, let's think about this. All right. I'm sorry, who identified that magnesium chloride would be one of the products?
I did.
Who's I? Guys, don't say I did, say your name. I can't see an I did.
Oh, it was me, Gates. I'm just kidding.
No, it wasn't, Keith. I
It was me too,
recognize your
actually.
voice. Who was I did?
It was
It was
Larry.
Larry, thank you. Larry, what else is produced?
Hydrogen gas.
Hydrogen gas. So, just from your knowledge right now, what would you say you're going to observe to prove that a chemical reaction took place?
Bubbles forming from the
Bubbles.
hydrogen gas.
Is everybody getting that? Are we good with that?
Yes.
All right. Again, I have zinc and copper sulfate. What type of reaction is this?
Same thing.
Same
single
thing.
displacement.
So if it's the same thing, what products are we expecting?
Zinc
Rigor.
sulfate.
And,
Copper.
okay, now, this may not be a fair question because you may not be familiar enough with it. Do you know what zinc looks like?
It's a goldish sort of metal.
No.
Is it like a kind of looks like a silver, like
It's a
small
dull silvery color.
thing?
All right, dull
Is that
silvery
an
color.
oxide?
I'm sorry, what?
There's a gold oxide of it. It's used in like coating nails and stuff. When you see like a gold coating.
Yeah,
on
there's a
tools.
reason for that. If you want to know the reason, I'll tell you later. But yes, you're absolutely right. It's used in galvanizing buckets and nails. Okay. And if you look at a nail, that's why a nail has that kind of dull grayish color on it. So that's what zinc looks like. Now, if the reaction goes, what products are you producing?
Zinc sulfate and copper metal.
What does copper metal look like?
Copper.
Brownish.
Brownish. Okay, so what are you expecting to observe if the reaction goes?
Precipitation.
Of what?
Copper.
You're going to expect to see brown stuff in your solution, right?
Correct.
I don't go for the big fancy terms of precipitate. Stuff is good for me. We have HCl and copper sulfate. What are the substances? What kind of substances do we have?
Well, HCl is an acid.
It's an acid, an ionic compound, and
then copper sulfate, isn't that a like solution?
well, it
Or is
can
that-
be.
Okay.
It can be, but copper sulfate itself, what is copper sulfate?
Ionic compound.
Ionic compound. So now we have an ionic compound mixed with an ionic compound. Correct, guys?
Yeah.
Yes.
So if we have an ionic compound mixed with an ionic compound, or a neutral metal, what kind of reaction is this?
Double displacement.
Double displacement. In a double displacement, what do you expect to happen?
The two anions to switch.
Okay, so if I say this, you're never going to forget this in your life. Anybody know what a key party is? Don't talk, Keith. Does anybody know what a key party is? And you're probably not old enough because it was a
think I know
thing in
what
the
you're talking
70s. Go ahead.
I don't want to say it.
You don't want to say it? If you don't
I
say
think
it, I'm
familiar
going to
with the
say it.
concept, though. Yeah, you can go ahead.
What happens? You get couples coming into this house, big mansion type house. All the men throw their keys into a bowl, and each one of the women go in and grab a set of keys. And what they do is whoever keys those are, they go with that particular man. So we have a switching of partners. If you want to think about it as the Flintstones, I have Fred and Wilma and Barney and Betty. Well, what happens is Fred sees Betty and says, "Oh, I want a brunette." So Fred goes and hooks up with Betty. Barney then goes and hooks up with Wilma. So the products of this, the cation of the first compound mixes with the anion of the second to make a new compound. The cation of the second compound mixes with the anion of the first to make a new compound. That is what double replacement is.
Oh, well said, Professor. Thank you.
I don't like that last question. So we're going to just go off on that. You'll understand why when we actually look at that particular reaction. What kind of substances do we have here? We have sodium bicarbonate and copper sulfate.
Baking soda.
What is baking soda? What type of compound is it? This will tell you. I'm sorry. Yeah, that'll tell you real quick. All you got to do is look at the compounds. If the first element in the compound is a metal, you have an ionic compound. So what kind of compounds are both of these? Come on, I know it's before 9
Ionic.
o'clock. What?
Ionic.
They're both ionic compounds. You got to be able to recognize the reactants to be able to predict what's going to happen. If I have an ionic with an ionic, double replacement.
Mr. Pete,
Yep.
did you mean to be sharing your screen?
Oh, for God's sakes, am I not doing that? I thought I was.
Yeah, no, I was so lost. I'm like, where are we getting this information from? Yeah, for the last 30
You had
minutes
me
or so.
looking
I
in
think.
the textbook.
Sorry. Guys, you got to talk to me.
The extra credit for the realization.
Yes, Gaith, you'll get the same amount of extra credit you got by showing up on Tuesday or Monday. I'm sorry, guys. I'm very, very sorry about this. I really, if I start talking like that and you're not seeing something, somebody tell me. I'm not sharing my screen, okay? All right, I've got sodium bicarbonate and copper sulfate. These are both metals. If you have a metal as the first element, you've got an ionic compound. If you have two ionic compounds, you are going to have a
Double displacement.
Thank you. Double displacement reaction. So what are my products going to be?
Is it gonna be like NaCu? I don't know if I'm doing this right.
Nope.
Okay.
Nope. You can't add an Na with the Cu unless you're making an alloy. And that's not what we're doing here.
Copper
does the-
bicarbonate and sodium sulfate.
I'm taking the sodium, linking it with the second anion. So I have sodium sulfate. I'm taking the
yes.
second cation. I'm linking it with the first anion. And by the way, guys, if you've got a metal listing your compound, if a metal is the compound is the first element, everything beyond the metal is going to be your anion. So we got that. All right. So our products are going to be copper bicarbonate and sodium sulfate. Again, what kind of reaction? By the way, guys, these are the same reactions we're going to go through when we watch the video. What type of substances?
Two ionic compounds.
Ionic. The trick here is NH4. It is the only polyatomic cation. So again, what are my products going to be?
Is it NH4SO4? I'm just trying to pair. Is that right?
You're good.
Okay.
Keep on going.
And
NH4, SO4, and what's left?
And then plus OHCU.
Cu. The cations always get listed first.
Oh,
Cu,
so, yeah,
OH.
yes. You're right. See, okay, yeah. CU.
Now, once you have put the proper things together, what you have to do then is you're going to have to balance the compounds first. NH4 has what charge?
A4.
NH4, what charge? Anybody?
+1.
+1. SO4 has what charge?
-2.
So how many NH4s do you need to balance off the SO4?
2.
So this reaction is going to make NH4 parentheses 2 SO4 plus
CuOH.
how many OHs? If I tell you the Cu has a +2 and the OH has a -1, how many OHs?
2 OHs.
2 OHs. And guys, legally cheat. I never memorized this crap. I literally never memorized this crap. I knew some of the stuff I kind of knew because it went over and over again. I knew SO4 is a -2, so my copper had to be a +2. I knew my NH4 is a +1, so my OH has to be a -1. Use what it gives you. Use the chemicals in the reactants to tell you what the charges are. Magnesium plus copper sulfate. What kind of reaction?
Single displacement.
If it's a single displacement, what are my products?
Copper metal and
Sulfate.
magnesium sulfate.
The magnesium is going to replace the copper, so I'm going to have magnesium sulfate, leaving neutral copper left. And I hope, nope, I got one more past this. All right, this is kind of a tough one. Okay. Now, if I have, and I'm going to go back. No, I'm not going to do that. I'm going to end show. No, stop it. Stop it. Okay. What are my reactions? What are my products going to be? First of all, what kind of reaction is this?
Here's a single.
Single?
Double.
Does this look like a single element,
Oh.
or does this look like
no.
a single element?
No, never mind. You're right.
So what
No,
kind
it's
of
a double. It's a
reaction is it?
double. It's a double.
So it's a double replacement. So the H is going to link with this. So I have H2CO3. What's my other product?
NaCl.
NaCl. All right. Now, when you mix a carbonate or a bicarbonate with an acid, it's an acid-base reaction. Look at this compound. Can you see a stable compound that you can make out of this?
Water and carbon dioxide.
Water and carbon dioxide. So basically, I would then have in this reaction H2CO3, then reacts to make H2O plus CO2. It's not an easy reaction. You either have to kind of memorize that bicarbonates reacting with acids and carbonates reacting with acids make a salt, water, and carbon dioxide, or you have to be able to see that this compound can break down to be two very, very stable compounds. 2 more to go. 2 more reactions to go. I swear to God. All right. I have NH4Cl plus H2O. What am I doing? Just by doing this, what am I actually doing? What is NH4Cl? What kind of compound? It's on the screen, guys.
Ionic.
It's ionic. I'm putting an ionic compound in the water. What am I doing? You need
Dissolving
to
it?
make pasta water. So you put table salt into your pasta water. What happens to the table salt?
Dissolves.
So if I put NH4Cl in the water, what am I doing to the NH4Cl?
Dissolving it pretty
I'm
much.
dissolving it. Remember what we said about dissolving. Is it a chemical process?
No.
No.
If I evaporate all that water away, am I going to end up with NH4Cl?
Yeah.
And thank God you managed to last through, well, I'll say about 9 of the 17 slides. I apologize about that. We're at almost an hour's pace. I'm sorry, this is going to go a little longer than normal. One second. I need to find something. Documents, Greg stuff, this class, summer. I'm going to do something for you. I am going to show you the answers to the questions in the quiz, or the possible answers for the questions in the quiz. First reaction you are going to do, your possible answers. You're mixing magnesium with HCl. Your possible answers, formation of a gas, formation of a precipitate, solution permanently changes color, solid permanently changes color. Solution gets colder, solution gets warmer. This is an unusual circumstance, guys. By the way, are you seeing, did I not share the damn thing again?
No.
Yeah, you
no.
didn't. I can't see it.
Sorry. Again. Where did it go? Okay. That's the PowerPoint. Oh, there it is. Okay, now can you see it?
Yes.
All right. These are your possible answers for magnesium and HCl. What I'm doing right here, guys, is I'm going to show you the video so that you're not going to have to view the video later. You can literally write your observations down right now. So these are the possibilities. Formation of a gas, formation of a precipitate, solution permanently changing color, solid permanently changing color. Solution gets colder, solution gets warmer. You got them all written down? Because I got to change the screen now.
Are these observations that we take from the video the ones that we organize,
Yes.
but with all like the procedure and stuff?
Some of the things are going to occur. Some of the things are not going to occur. What you're getting graded on is if you say something occurred and it didn't, you'll get marked off for it. If you say something didn't occur and it did, you'll get marked off for it. Are you understanding what's saying? You're
No,
to
I mean-
mark each one of these that occurs.
No, I understand that part. I was talking about the observations we make in the video.
Ask your question again.
So in the video of them doing the reactions, and we have to take down our observations like we're going to do in a second, is that what goes in our notebook?
Yes.
And then that's what we take a picture of and scan and upload at the end of the week.
Partially. That's the data section of your notebook. You
Yeah.
have to do everything else though.
All right. Thank you.
All right, we good with this?
Wait, Professor. So my question is, because I remember last semester it was more like a quiz type of lab. So this one is going to be different now. We're going to be sending you pictures of our notebook and stuff.
Yes. Gaith, stay
Yes.
after class. Stay after class. I'll show you what you have to do.
Okay.
This is why you should always attend.
I'll be staying too.
That's fine. I don't mind whoever wants to stay.
Magnesium and hydrochloric acid. So we've got bits of magnesium here, so go ahead and grab one of those, please, Jim. We're going to put them into a test tube. Just use one of the smaller ones, I think, Jim.
They're similar in size.
Okay. And then we're going to add, what do you reckon, about a couple of fingers worth of
Yeah, just enough
HCl?
to sort of cover the surface.
What's the molarity of the HCl there?
This is a 1.0 molar hydrochloric acid.
Okay.
Just be careful not to spill this. And I have just enough to cover the surface of the magnesium.
Okay, let's look at this. So when we're doing observations, what we're interested in is what we can see, what we can hear, and what we can feel. Now, when we put our fingers around that, it feels warm, right?
It does. It's like it is getting warmer.
Yeah. A couple of other things you'll notice. You'll see the bubbles there. You see, it's not white. That solution hasn't turned white. Those are just bubbles that are coming off the magnesium. Now, the other thing, you'll have to take my word for this, though, is that the magnesium is actually dissolving. It's actually turning into magnesium ions. So if we let this sit for long enough, which we're not going to do here, we would actually see that entire piece of magnesium disappear at some point. And then the bubbling obviously would cease at the same time as well. And when I'm talking about what we hear, if you listen very closely, you'll hear some fizzing as well. And that's just really the bubbles coming off the surface of the magnesium.
Okay, those are your possible answers.
For fizzing and bubbling, would it go under formation of
want-
gas or no?
I'm sorry, what do you think?
Yes.
Yes. I just, right at this point, I don't want anybody really commenting. A question like that is fine. A question of clarification is fine, but I don't want you literally saying something like, well, is it really a formation of gas? Do you understand what I'm saying here? Okay. Your second observations. There we go. When we mix zinc and copper sulfate, your possibilities are formation of a gas, solution changes color, solid changes color. Solution gets colder. Those are your possibilities. Are we good? Those four things. Are we good, guys?
Yes.
I need to have, guys, the longer you take to respond to me, the longer you're going to be in here. Okay, I'm going to stop sharing this screen. I am going to go back to this screen.
This next reaction is the zinc and there's a 1 molar copper sulfate that we're using here.
Yes, it's the dark blue and it's 1 molar copper.
Yeah, could you bring it up to and we'll bring that up to the camera there. So that one, just move it over a little bit. That one's 1 molar. You see it's a dark blue. Then the other one that you might have access to, go ahead and let's bring the other one up, is this lighter one. That's still copper sulfate as well, but that's 0.1 molar. It's an obvious difference between them. One is used One has one's much darker than the other, so you'll make sure you use the correct one. But we need to use the 1 molar here for the zinc. So we're getting a test tube here. We've got some zinc. The zinc is just a piece of metal here. There we go. Oh, would you put that? Sorry, move it over a little bit, Jim, so we can see it. Yeah, and then stick it in.
You may need to bend
Can't
the
really
zinc.
see it. It's a
Make it
dull
fit inside
gray
the test tube.
color.
Oh, it's possible. Yeah. So let's just show them what it looks like inside the test tube there. Move it up a little bit, please. No, sorry, move it towards the camera. Yeah, and you can see now it's in there, and now he's going to add the copper sulfate. Okay, make sure it's in the camera, Jim. There we go. Perfect. A little bit over. There we go. Perfect. So that's the zinc in the bottom. We're adding the copper sulfate here. All right, now a couple of things you can observe here. Give it a little bit of a swirl there, please, Jim.
I see dark.
Yeah, let's put it in the camera here, and you can see. Let me. Yeah, all right. Now take a look. What do you see, Jim?
I see the surface of the zinc is turned like a dark color.
Right. So it's almost a brownish color, isn't it?
It is brownish, but it is hard to tell because the interference with the blue color from the copper sulfate solution.
Now, speaking of the copper sulfate solution, what do you notice about that?
Its color is becoming slightly less blue over time.
Yeah. Yeah. If you compare that, let's bring the other one up and compare it. You can see it's almost like a greenish color now when you compare it. So you can see something's happened to the liquid too. The liquid's changed its color a bit as well. Do you see any bubbling, Jim?
No, nothing obvious.
No. Okay, no bubbling. Now the other thing that's important here. Put your hand around it. Let's see if there's any heat.
Nothing obvious either.
Yeah, nothing obvious heat. No, we don't hear anything because there's no fizzing.
No.
So it looks like that's pretty much it. Let's put this back in the camera here, and we'll just you can just see.
I've noticed also if I shake it a little bit, some of that brown material, which now is definitely brown, is flaking off the surface of the zinc.
Yeah, it's almost like it's copper colored.
I believe so. Looks like a penny.
Yeah, it's interesting.
Nudge,
All right,
wink,
put it back.
There we
in
go.
the
If you
thing.
look at it on the surface on the glass of the test tube, you
Yeah.
can see some of the material.
Right, excellent.
Again, your choices. Jonathan, don't be yawning at me. Are we good, guys?
Yes.
Next one is copper sulfate and HCl.
So, Professor, just to clarify, so obviously I don't really have time to write all these information down. So, can we go back?
No, okay, that's fine. I've provided
Because
the
I'm writing down the information.
Gaith, I have provided the list for you, and the videos are also on the website. If this list is not there, I will make sure it gets put on there momentarily after the class. I believe it is on there. So you are basically going to have the list and the videos if you want to review these. Okay.
Awesome. Thank you.
Again, stop share. By the way, are you kind of getting what's happening here, guys? Is this a good way to present this for you?
Yes.
All right, so this one requires 0.1 molar CuSO4. We talked about this in the previous one. Notice how it's lighter than the other one. You can see the other one in the background. It's that dark blue color. But we're interested in this light one, so we're going to have a CuSO4, 0.1 molar. We're going to put that in, and then we're going to add HCl to it.
Do you notice that they're not really measuring out the quantities? He's not putting it into a graduated cylinder and getting exactly 1 milliliter. You know, do you see how he's just doing it by eyeball? That's what's happening when you're doing qualitative analysis. Qualitative analysis, you're not so much interested in how much you have, you're more interested in what's happening. And you don't have to really precisely measure everything.
So you'll notice the initial color of this copper sulfate is very light blue, almost a greenish color, so like a cyan. Would you put that in the shot, please? All right, you can see it there. All right, go ahead and add the HCl. We'll see what happens. And I'm looking at it, and I don't know, it just looks pretty much the same to me.
Nothing obvious.
Yeah. Any gas formation?
No bubbles.
No bubbles, so you're not going to hear anything. And when you feel it, do you feel anything?
No,
okay,
I
let's
do.
put it back down in the shot here. Yeah, you see, it looks pretty much the same as what it was when we started. I think that's why it's important that we use the 0.1 molar. If you use the 1 molar, I think you might see a color change. It's possible, but I still don't feel like there's really anything happening at all.
The color, can anybody surmise why there might be a color change?
Because you would be diluting it.
You're diluting it. You're adding more water. The HCl has water too. So by adding the HCl, you're diluting the thing, so the solution possibly could fade a little bit. Your possibilities. I believe that's all of them. Yeah, that's all of them. Anybody need more time? Okay. Next experiment, you're mixing copper sulfate with sodium bicarbonate. And those are the 5 possibilities. We good? Anybody need more time?
No.
So we're using the 0.1 molar copper sulfate again. That's the lighter one, lighter bluish one, and then we're going to use the sodium bicarbonate. So let's add the first one, the copper sulfate. Okay, it's good. Now let's add the sodium bicarbonate. It's NaHCO3, right?
Yes, NaHCl3.
Okay, let's take a look at that in the camera. All right, what do you see, Jim?
I see some white particulates.
Okay, do you see any
Forming.
bubbling? You know,
not obvious.
Not obvious. Now, sometimes, you know, it can depend. If your test tube is not very clean, if it's got some sort of acid in it, it's possible you might actually see some bubbling with this one. But if your test tube's completely clean, put it down a little, shot a little bit, please, Jim. All you'll probably see is what we're seeing here. Now you'll notice, look at the little bit lower. Look at the very top, and you'll see that it looks like the solution's changed color as well. It's almost like the solution has become almost colorless, wouldn't you say, Jim?
I agree, yes.
Yeah. And if you look at we do have a particulates in there. It's definitely some solid coming out of this. Can you look at the heat? See if we can.
No, it's not changing temperature.
No, not changing temperature. So there's no heat changes. There's no fizzing, so we're not hearing anything. So I think that's all we're going to see with this one.
All right, Professor, my screen was a little blurry, so all we saw was solution changing color. That's it. Right?
I'm not told you, Gaith.
No.
I'm sorry. I'm not going to go, and that would be like me answering the quiz for you, Gaith.
Okay.
If you want to, Gaith, go back and look at the video, and perhaps something that they've said may be able to clarify your question. Okay, Gaith?
Yes, sir.
Are we good, ladies and gentlemen? All right. Copper sulfate and NH4OH. The 6 possibilities. Are we good? Anybody need more time? Fair enough.
So this one is the copper sulfate, 0.1 molar, again the lighter one, and ammonium hydroxide. So go ahead, Jim, and let's put the copper sulfate in. So that same light bluish green liquid, and now we're going to add the ammonium hydroxide. Okay, let's bring it close to the camera here. We'll see what's going on. A little bit lower, please, and a little bit higher. There we go. Give it a little bit of a swirl. All right, so we're looking at it. It looks like there's definitely a precipitate there, wouldn't you say?
Yes, there's a definite precipitate.
And also, when looking at that solution, I'd say if you certainly look at the top of the solution, it seems to have become almost colorless. So I'd say that what's causing the blue color there is more the precipitate than the solution. So I definitely think the solution has changed color as well. Doesn't seem to be any changes to heat, right?
No.
And I don't see any bubbling. I don't hear any bubbling either.
Are we good, ladies and gentlemen?
Yes.
I think we're about over halfway done. Magnesium and copper sulfate. Only 2 things are listed. Are we good, guys?
Yes.
Yes.
This one is the magnesium and the copper sulfate. So we've got the magnesium there, and we're going to stick that in. And now we're going to add copper sulfate. So it's a 0.1 mole of a lighter one that we're using.
Yes.
Alright, that was good. That'll be fine. Alright, as you can see these little brown particulates coming off there, and you can see them, they're forming also on the metal surface itself. Take it down just a little bit, please. There we go. I'm going to zoom in on that. Move it just up a little bit, please. Alright, you can see those particulates. Look at the color of the solution as well. I also see some bubbling too that's occurring here. Sometimes you'll see the bubbling, sometimes you won't, but I'm definitely seeing it here. Could you put your hand around it, Jim, see if there's any changes in heat?
It's not obvious.
No, not obvious, okay. Yeah, so if we see the particulates and we look at the solution definitely looks lighter than what it was as well. Could you? Yeah, so I think that's pretty much all we're going to see with that one.
These two are the only two that are listed. Are we good?
1 second, Professor. Sorry, my camera froze.
Nope.
Almost done. Okay.
HCl and sodium bicarbonate. Those four things. Anybody need more time?
Alright, so we've got the HCl here and the sodium bicarbonate. Which one are you going to put in first, Jim?
I'm going to put it in the HCl.
Okay, so it's going to put the HCl in. The HCl is just a clear colorless liquid. Doesn't look any different from water really. Okay, so he's put about 2 fingers worth in there, and now he's going to add.
This is the
sodium bicarbonate. Yeah, so make sure it's sodium bicarbonate, not sodium carbonate. Okay, let's bring that a bit closer to the camera here. Give it a bit of a swirl. Yeah, what do you see there, Jim?
I see lots of bubbles.
Yeah, let's put it down a little bit. See any precipitate?
I do not know.
No precipitate? Okay. Put your finger around it. Any changes in heat?
Not obvious.
Yeah, not obvious. Okay. Yeah, and the solution looks like it's just remained colorless as well, doesn't it?
It did, yes.
Yeah. All right, that's it.
Just these four. Anybody need more time? Last one. We're mixing NH4Cl with H2O and crap. Formation of a gas, formation of a precipitate, solution permanently changes color, solid permanently changes color. Last two, gets colder, gets warmer. Are we good, guys?
Yes.
Yes.
And we got about 2 more minutes left.
So we're doing ammonium chloride now in water. So the ammonium chloride here is a solid, and Jim's going to go ahead and put a little bit of that into a test tube. It's kind of a smelly solid, isn't it?
Yeah, keep your nose away from it.
Yeah. So he's going to put it maybe, what, a couple of scoops?
Yeah, enough so I can see clearly at the bottom.
Yeah, that's good. We're going to add some water to it as well, and we'll see what happens. Could you put it in the camera, please, Jim, when we're doing this? That's good. And he's going to give it a bit of a swirl around. Now you'll notice that the solid is disappearing. And what do you notice when you put your fingers around it?
It is getting colder.
It's getting colder, okay. All right, let me say a little bit about this, because you know, you can see that the solid has disappeared and it has gotten colder. Now, this doesn't necessarily mean that it is a chemical change, because what can happen is that some things can get colder and just dissolve without really being a chemical change. Because I know with ammonium chloride, what happens is that I could actually take that solution, evaporate it, I can get the ammonium chloride back, which makes this more a physical change than a chemical change. So the fact that it cooled down really doesn't indicate anything chemically was going on. There were no changes in color of the solution, it looks the same.
No.
There was no precipitate, no bubbling, nothing else to indicate that there was a chemical change going on here.
Okay. We'll stop that. Stop share. Possibilities. Gets colder, gets warmer. Solution changes color, solid changes color. You got a precipitate or a formation of a gas. Are we good?
Yes.
Okay, I'm going to stop share for a second because I want to see the actual. I want to see for myself whether I put that in there. Okay. The video you just saw is right here. Oh, crap. So those answers I just showed you are at the very bottom here. Okay. If you want access to them, print them out or whatever, they're right there. The video is up here if you want to review that to make sure you get the right answers. Yeah, I know I've been going, this is longer than a normal period will be. Sorry, but I felt the need to go through that with you guys. if I am going to go through the results, the last thing I do when I'm teaching a lab course is I go through the results section. I let you see it before you're actually doing the answers, just in case you have some questions about that. Again, if you notice, the first question here is just what we went through. I'm sorry, I got to move the pictures over. Next question asks you whether that's going to be chemical or physical. Again, question 3, what did you observe? Chemical, physical. What did you observe? Chemical, physical. It's just exactly what we went through just right there, only with the extra question, whether it was chemical or physical. Okay. Are we good up to that point?
Yeah, so that's the lab basically regarding the questions of the video we watched, correct?
Yes, up to that
Okay.
point. Now you have to come to the hard portion of this. And that is, it's going to give you the reactants. You are going to have to predict. You're going to have to predict the exact, you're going to have to get the chemical balanced as well as the entire chemical equation. You're going to have to balance the products. Understand, you're going to have to balance the entire chemical equation to make sure that the products are balanced, but all you're going to see over here are the products portion. Anybody need that explained again? Understand, he is very tricky about this because he will do some things like MG. He'll change the subscripts on you. And some of these may balance, you can make them balance, but it's not the right chemicals. Does that make sense to you guys? And you have to do that for each and every one of these. That is going to be the hard part of this particular experiment. Now, point of fact, you will see this box on every results section. This is a place where I can give extra credit points if I desire. And generally speaking, my philosophy is if you are doing the laboratory and you do an outstanding job, later on in the semester, we're going to be doing a titration of a base. We're standardizing the base. Some people are able to do this very well, and they're able to get results that are very close to one another. I give extra credit for extra good results. Unfortunately for you all, you're not actually performing the experiments, so I don't feel I can give you extra credit. It doesn't really matter, guys, because ultimately, if I look at the end and I see the grade percentages are a little low, I will lower the percentage for an A, lower the percentage for B. Does that make sense, guys? If you're artificially being raised by the extra credit, that's going to artificially raise the percentages. So ultimately, it doesn't matter. Extra credit just makes you feel good.
Speaking of extra credit, I have a question about the pre-course quiz. There was
It's
an
already
extra
been
credit.
done. Don't worry about it.
Okay, I was wondering about the wording.
If what happened is, yeah, I know about it. It happened for some reason or other. What I did was I transferred my quiz from HCC to SPC, and the one question, the graphic didn't translate over. Okay, so that one question you will be getting the 5 points for.
Oh no, I meant the extra credit one.
I'll just, don't worry about it.
Oh,
I'll,
okay.
I'll just,
Alright, cool.
I'll give you the extra point.
Yay.
All right. Questions about the results section? Now, you're going to have also a post-lab question. And what the post-lab is based upon is they're going to give you scenarios that are based on what you actually did. And you're going to be asked to make deductive conclusions on that. Okay, basically they go through a series of questions on whether something is a physical or chemical change. Then they give you a scenario. Remember, it's the difference between the property and a change. When it's worded like this is a semantic thing. You have to look at the question and you have to deduce whether it is happening now, whether it has already occurred, or whether it could occur. Does that make sense to you? If it could occur, that means it is a property. If it is occurring or has occurred, that means it is a change. Now, the other thing is, if you look at this, if you look at the question and you really firmly believe that you answered it correctly, if you email me and if you tell me why you believed what you believed, then you will get the points back. As a matter of fact, the quiz I gave in lecture, I don't even know if somebody's here that took it. The quiz I gave in lecture, I had one such incident. The student basically didn't like the way the question was worded, and he gave me his point of view. I agreed it was a little bit ambiguous, so I gave him the point. Now, be aware that I changed the question. I reworded the question after I heard from him. So if you answered the quiz after him, it's that particular question is set in stone. But if you have any question about something like that, bring it to my attention. I'll look at it, think about it, and then I will make a decision. More than likely, you'll get the points. And I think that's all that this is involving. 5 questions. You have to determine whether it's a physical or chemical change. They don't even go with properties. They're telling you they're all changes. Okay?
All right, Professor, I do have a question.
Uh-huh.
Okay, so I'm looking at the course schedule right now for this lab class. So pretty much I get the gist of the pre-lab, the safety quiz, syllabus quiz, and then the pre-lab for density. The only thing that
Go ahead.
I'm sorry. Okay.
Go ahead.
The only thing that kind of confusing me is because I'm not familiar with is the chemical and physical changes lab book. That's not really something I'm familiar with, and I just wanted some.
Gaith, I told you I was going to go over that after class, right?
Oh, I thought we were after class.
No,
Okay.
no.
Sorry.
As far as I'm concerned, I'm done with my presentation, guys. Again, normally speaking, labs are an hour. My explanation goes for an hour. Normally speaking, I just felt it was a good idea for me to show those videos with you in case you had questions. If you don't have any questions, then I will see you on Tuesday. Understand the way the schedule works. On Tuesday, we are doing the density laboratory. So you have to do the pre-lab on Sunday night by midnight. Now, next Wednesday, I got to even look it up. I can't go more than 2 weeks in advance. Is it the hydrate lab? Okay, so the 23rd, midnight, the pre-lab for density is due. That is the pre-lab for density is due. And if you haven't done the safety and syllabus quiz, that's due by then too. Now, next Tuesday being the 25th of May at midnight, you have the pre-lab for hydrates and you have the results and the post-lab for chem and physical properties due. My suggestion to you is to do this lab as soon as possible after I go through the presentation because it's freshest in your mind. Because literally speaking, guys, between midnight Sunday and midnight Tuesday, you don't have a long turnaround time. If you wait for the last minute, then you're going to have a whole bunch of stuff going on. And remember, you have lecture. Lecture is going to have homework. It's going to have quizzes. It's going to have forum presentations. So you're going to really have to be organized to get through this summer session. That's all I got to say, guys. I have to stay with Gaith afterwards to talk about the notebook and anything else. If you'd like to stay, you're more than welcome.
Thank you, Professor.
Take care, Larry.
Thank you.
Bye.
Thank you. Have a good rest of your day.
Bye. So long.
Thank you.
Farewell. Everybody else wants more explanation? Okay, we'll go through that again. Okay, again, you're going to have to sit through a whole bunch of stuff. Do you want me to go through the notebook first or the whole bunch of other stuff first?
The notebook, please, first, just to kind of get a quick glance on what's going on.
And that's Gaith. Gaith, you're the reason I'm going through this other stuff.
Oh, well, yeah, go ahead. Do whatever you want,
No,
Professor.
The
I'm all
other
ears.
three of you. The other three of you. Is that basically why you're still here? The notebook?
Well, I missed the first lab, so I just.
All
wanna,
right, good.
you know,
I'll go through
any-
everything with you as well.
Yeah, any information is good.
All right. Since you asked for it, we'll go through the notebook. Each experiment, you're required to go in and give a notebook. So if I go into the chem and physical properties, you're going to see right down here the lab book. This is where you're supposed to put it. And I'm not totally familiar with this. Guys, you are more able than I am. Basically, you're going to be taking pictures of your lab notebook. They want you to draw a line through it and sign your name on it. Do it the best you can, okay? But then you're going to take these pictures, apparently save them, and then you're going to add them as attachments. And you're going to go to the very end here, and I think it.
Professor, if the word lost was a person, it would be me. I don't know what you just said.
Gates, you're gonna have to take pictures of your notebook.
Right, but what are we writing in the notebook?
I'm gonna go through that in a second, Gates.
Okay.
Okay. Basically, you're gonna have to drag and drop your assignments and put them below. You're either gonna upload or drag and click. You're gonna be able to do that. Then apparently I have to upload something. Okay, you're gonna upload something and then just hit the submit to Dropbox. Are we clear on that? Does that seem fairly easy?
Yes.
All right. So what's going in the actual notebook? If you want the PowerPoint I went through or the example notebook, they are available to you. If you go down to instructor notes, (2045) instructor notes, it's way at the bottom. And you got to go way back up to the top. There is the laboratory notebook. Click on it and the PowerPoint will be distributed. You can actually look at it this way, or you can download it into looking at it PowerPoint wise.
So
And
for
I know
for,
it'll be up. The PowerPoint will be up in a second. I've got to, as soon as it loads, I got to stop share and reshare. Okay, you seeing lab notebook up there?
Yes.
Okay, slideshow. All right. These are the sections I want of the notebook. Objective, chemical hazards, procedures, data table, calculations, and conclusion. Objective is a simple declarative statement. What are you doing? Today, what did we do? What did this experiment involve?
making observations on reactions or
But
physical
what
and
did you
chemical.
do? Ultimately, what did you determine? What did the results
Whether
section ultimately ask you?
whether a reaction was a physical or chemical change.
Determining physical and chemical changes of mixed chemicals. Isn't that really what you did?
Yeah.
Yes.
Simple statement. That's all I want. When we're doing the empirical formula objective is going to be to determine the empirical formula of an unknown compound consisting of copper, chlorine, and water. Simple statements. Chemical hazards. You got to look this is going to be a pain in the ass this week because there's a lot of chemicals, but you got to Google SDS, name of the chemical. And you're going to find the long-term and immediate hazards within. SDS stands for safety data sheet. One safety data sheet gets submitted with every chemical every time you buy it. So, I'm sorry, I'm going to make sure that this is a scam and then it's
We've
got to
been
be a
trying to
scam.
reach you about your car's extended warranty.
What's that? Oh, yeah. Okay, so you're going to look at these immediate and and long-term hazards that are written in the SDS, and you're going to handwrite them in your notebook. Make a synopsis of it. You don't have to write the whole, look, you look at that whole long thing, lead nitrate. I copied this directly from an SDS sheet. Okay? You don't have to write each and everything that's on here. Can cause skin and eye irritation. Can cause lead poisoning. Can cause, you don't even have to put this big long word in there. Can cause the blood to not deliver oxygen. Can have toxic effects in blood forming organs. Long term, can cause these things. Do you understand basically what I'm asking for? Really and truly, I'm just continuing this for when you go on to Chem 2, because I require it in Chem 2 because you're physically working with the chemicals. I want you to be aware of the hazards you're working with. And if I make you look it up, if somebody is pregnant, then maybe they'll see, oh my God, I better bring this to Mr. Popovich's attention. In which case I'll excuse them from that particular experiment. Any questions on the hazards?
No, sir.
Do not write me a encyclopedia. Just kind of give me a synopsis of what those hazards are. I just want to believe that you have at least read through them. Procedure. Step by step of how you're going to do the experiment. Handwritten, do not plagiarize. These have to be in your own words. I've got an example of what I want step by step. I prefer bullet points. I prefer bullet points because they're easier to read through than a paragraph prose. However, if you insist on writing paragraph prose, I have to accept it. Step by step, you want to write these so that if somebody is just reading your notebook, they could replicate exactly what you did. Questions on that?
Yeah, so for this lab, we had A, B, C, D, E, F, G. Do you want us to explain every single part?
No. Just explain in general terms. Okay? I'm not going to make you, by the way, remind me I said this. Okay? Who's speaking?
Garrus?
Garrus, remind me that I said that, okay? Because sometimes I say things and then a student does what I say and I will have forgotten it a week later. I'm just being honest here, okay, Garrus? Remind me I said that.
Okay.
Yeah, just go in general terms. Just say something to the effect of, we're determining the chemical changes by mixing chemicals. If we had a solid, we put the solid in the test tube, then added the liquid to it. If we had the liquid, we added equal volumes of the liquid to one another. All right, Garrus, it's ridiculous for me to make you do each and every one of those 8 steps, okay?
Okay, and like, do we need to mention washing, like the equipment and stuff? Because the video didn't really specify that, so I didn't know for sure because I saw it on this example.
Garrus, there are certain things that are considered good chemical practice. Okay? If you are going to do an experiment, it makes good sense to avoid cross-contamination by cleaning your glassware. Also, you don't have to list. I mean, I've had people that say you have to collect a graduated cylinder, 250 milliliter beaker, spot. You don't have to list getting the equipment, okay?
Okay, and are there any other like typical chemical procedures that might not explicitly be mentioned in this lab?
I'm not understanding what you're saying.
Well, like how it's just typical to wash the crucible, but they didn't mention that specifically. Is there anything else like that that we need to include just to make
Well,
sure
in
we
this
don't miss it?
particular case, if you're referring to my first couple lines there, I didn't use a crucible. You would have been washing and drying a test tube. Again, Garris, that's good chemical practice. I don't necessarily have to see good chemical practice, things that, yeah,
So I feel like we just don't need to overthink it. We can just be very general with the
use
because yeah.
use the procedures that are given to you in the manual. Okay, use those procedures as a template, but don't copy it word for word. Put it in your own words. Garris, does that kind of make sense to you?
Yeah.
Garris, I'm not going to be, all right, Garris, there are 23 people in this class. I have to grade 23 results sections and 23 lab notebooks. Do you think after the first couple weeks, I'm going to be scrutinizing these all that strenuously? All right. My whole goal, I want you to be able to know how to write a notebook. If you demonstrate that to me once, then I'm going to put a note in my grade book. Garris understands how to write a notebook. So I'm going to basically scan your lab notebooks for the rest of the semester, and you'll get all 9 points. Make sense, Garris?
Yeah, I just want to make sure I'm including everything because I know it's going to be very harshly like graded the first time around.
Yeah.
Listen, man, just give the professor some money, send him some food, you'll be fine, all right?
This is from a person that's had me in the past. Garris, you'll be fine. All right. First of all, Garris, there are 117 points that you have possible, and I can only put in 100. I can only divide by 100. So you've got some extra credit already built in there, Garris. Does that make sense? For
Yes.
that particular reason. So everybody understands you're writing into procedures detailed enough that somebody could replicate your results. Data table. You may copy the table that is written in your laboratory manual. And then the data table will be kind of organized fairly nicely. You're going to have to handwrite your results into the data table. But the thing is, it has to be implanted into your notebook. It has to be pasted, glued, taped, or stapled into your notebook. If you just put the data table in there in a loosely fashion, it doesn't count. You can also handwrite the whole data table if you like.
Hey, professor, I don't want to waste your time. Can you just, because I was trying to find the data table. Where do you go through that? I don't know if it's just my area.
It's in the manual itself. Gaith, let me go through this. Gaith? Let
Go
me
ahead.
go through this and I will go back and answer that question in a second or two. Just
Okay.
remind me when I get done here, okay?
You got it.
Okay, do you want a whole page set off for our data, or can we like put it below the procedure if they're like on the same page?
If they're on the same page, you could put it below the procedure. That's fine.
Okay, and then for
Technically speaking, Garrus, you really shouldn't have any blank portions of your lab notebook. Because you remember I said that my notebook got subpoenaed? If you have blank sections, that implies that you went back at a later time and could have filled some information in at a later time. Does that make sense, Garrus? So if you have a blank portion of your notebook, you are supposed to put a line there and sign it saying that there's nothing there. Does that make sense, Garrus? But again,
yes.
I'm talking when you get actually out there. At this point, it doesn't really matter. I'm not going to take off points for that.
Okay, and then for this lab, can we just print out the table that's in the student data and fill that in?
Yes, that's what you can do for every lab.
Oh,
Garrus,
okay. Because
you can
said
you can print it out. Garrus, you can print it out. But what I'm saying in this slide, if you just print it out and just slide it into the notebook, that doesn't count. You have to literally paste it, glue it, do something so that it becomes a permanent part of your lab notebook, okay?
Oh, okay, I got it. Thank you.
Do not include calculations. You're going to be tempted because you have one line here and another line right below it. Oh, I could just put the calculation to go from this line to that one right in between. I do not want that. What happens is if you're a person reading this that hasn't written it, it becomes extremely confusing. So do not include calculations in your data page. What I'm looking in the data table for are correct measurement readings and correct significant figures from the calculations. The calculation, separate section. I want one calculation at least from birth to death. In other words, when you're doing a chemical experiment, part of the experiment is taking measurements or making observations. If you're making observations, you're not going to have the calculations. This lab notebook you're submitting will not have a calculation section. By one calculation, birth to death, I need you to put every calculation you made that took it from the measurements portion to the end where you drew your conclusion. If you do multiple trials, you do not have to include multiple calculations. For example, in about 3 or 4 weeks, we're going to be doing standardization of a base. The base concentration shouldn't change. So each time you do that calculation, you should be coming up with the same answer. And you're doing the same calculation for 3 trials. You can include all the calculations in your calculation. I'm saying you don't have to. If the calculation is the same, you don't have to include it. But I do want it from the measurement stage until you make your final conclusion stage. An example of that, if I'm doing my empirical formula, I want to find the mass of the hydrate. So I put weigh the crucible. I weigh the crucible and the salt before I heat it. I have to subtract the two of them to get the mass of the hydrate. Then part of the procedure for the hydrate is I take my I take my crucible, I heat it up. That drives all the water away. Let the crucible cool. I put that on the scale. I now have the weight of the salt without water. To get the weight of the anhydrous, or the weight of the salt without water, I take the crucible weight and the anhydrous, subtract out the crucible weight. I now have the mass of my anhydrous and mass of my hydrate. To get my mass of water, I subtract mass of anhydrous and mass of hydrate. That gives me my mass of water. To determine the percent water, I take my mass of water divided by the mass of hydrate. This gives me the percent water. Are you understanding what I mean by all the calculations from the measurement stage to the conclusion stage? We good? Okay, this is, I go through some more calculations here. That's because it's the empirical formula. I just synopsized it. Last section, conclusion. The first statement in your conclusion should answer the question that was raised in the objective. If the objective was to determine the density of an unknown solid, the conclusion should be the density of my unknown solid was 1.82 grams per milliliter. In my example here, my objective was to determine the empirical formula of an unknown compound containing copper, chlorine, and water. For my conclusion, my first statement is going to be the empirical formula was CuCl2.5 H2Os. In the conclusion, you need to propose one error, one thing where your experiment could have gone wrong. But what you have to do is you have to analyze that error. And you have to show how the error affected your results. Okay, I'm doing the density of a solid. All right. When I added my solid to my liquid, some water splashed up and beaded up above in the empty glassware in the graduated cylinder. What happened then is that my volume that I read was less than it should have been. If the volume was less than it should have been, then I was dividing by a smaller number. If I'm dividing by a smaller number, then my density should have been larger than it was. Are you understanding the error interpretation?
So like basically we're just doing some kind of an educated guess. If we did something wrong in the procedure, this would have happened, right?
Yes.
Okay.
What you're doing is you're saying, okay, this could have gone wrong. I weighed my sample and spilled some of it. This means that my hydrate weight was too low. If my hydrate weight was too low, then that would have meant that my percentage water was going to be too high because I was dividing by a lower number.
Okay, got it. Makes sense.
There's also a numerical thing. If I give you what the correct answer should be. You have to determine how accurate you were. The way you do that is something called percent error. And the formula for percent error is actual minus expected divided by your expected value. For example, if I tell you that the correct empirical formula for copper chloride should have been CuCl2, that meant that the molar ratio between the copper and the chlorine should have been 1:2. If you did the experiment and you came up with your mathematical calculation that that ratio was 2.10, that is the actual value you came in. Substitute that in for actual value. The expected value was 2. Subtract those two numbers, divide by 2, and multiply by 100. That will give you your percent error. Questions?
Yes, so for the conclusion on this lab, do you want us to give the conclusion for each A, B, C, D, E, F, G, H? Because it's asking to determine the physical and chemical changes?
Yes.
Okay.
Okay. Sometimes, like in determination of molarity of a base, when you are doing a experiment, sometimes you should be getting the same result each and every time. If you're testing for the concentration of a base, the concentration isn't changing each time you do a trial. So what you have to do is you have to determine how precise you are. You can put a numerical application to this by doing something called a standard deviation. Now, in a standard deviation, you take all your numbers, add them up, divide by the number of trials, you get the average. Then what you're doing for the standard deviation, you're taking your trial 1 value, you're subtracting the average from it, but you're taking the absolute value. Whatever this answer is after the subtraction, you make it a positive number. To that, you add the absolute value of trial 2 minus the average, plus trial 3 minus the average. You go all the way out to trial n minus the average. Remember, all these numbers on the top should be positive numbers. You add them all up, divide that by the number of trials. That is your standard deviation. So if I have 5 trials that I did of my empirical formula, and I came up with molar ratios of 2.03, 2.07, 2.25, 2.05, and 2.09. Those are my actual results. I kind of fudged this a little bit. I dropped. Okay. Let's look at our data. Does one of these results seem like it's incorrect? Is there one of the results
There's an
that seems
outlier of
different? What?
2.25. There's an outlier for sure. 2.25.
Okay. If you can see within your data that there is an outlier, just drop it. Okay? You don't need to include it because something happened wrong in that particular experiment. You know, something happened that you may not have even seen what went wrong, but something happened and you're fairly sure that's a bad result. Throw it away. Okay, so now I have the 4 remaining values. I have my average. So I'm taking my first trial minus the average, absolute value, I get 0.03, a positive 0.03. even though this number is negative. I'm sorry to harp on that, but believe it or not, there are some people that don't understand absolute values. So even though this is a negative 0.03, I make it into a positive 0.03. Second trial minus the average, third trial minus the average, fourth trial minus the average. I take all those differences, add them up, divide by the number of trials I have. So what that really means is that because I took the absolute value, this number could be plus or minus what that standard deviation is. So if my average is 2.06, what the standard deviation is saying I'm real certain that my results lie somewhere within this range. I add 0.02 to my average and I subtract 0.02 from my average. So that means that my real result is definitely between 2.04 and 2.08. Are we good, guys? Good on the notebook?
Yeah, Professor, I'm not gonna lie, this is a lot of detailed information. So let's hope you don't butcher it, because I feel like I'm gonna butcher this. I mean, it seems fairly simple.
Gabe.
Just gets to the
I was telling Garrus earlier, there are 13 experiments. Okay, Gabe? Gabe? There are 13 experiments. Each one is worth 9. If you do that multiplication out, you get 117 points, Gabe, right?
Yes.
When I am doing my final grade calculation, I'm only counting 100 of those points. So right off the bat, you have a possibility of 17 extra credit points.
Oh, okay.
All right. So we're doing this because we know the notebook is a learning curve.
Got it. Okay.
All right.
Appreciate it. Yes, sir. So I'm assuming all of these, the notebook and all the other ones are due before our next class, correct?
It's all the assignments are due 6 days after I present the Zoom meeting, midnight.
Okay.
So
Got it.
this laboratory we did today, you're going to have to turn in the results, post lab, and the notebook. For this lab, you're going to have to do it next Tuesday at midnight.
Got it.
Also, you're going to have to do the pre-lab of the class of the experiment we're performing. I'm talking about the next day, which is the hydrate lab.
Got it.
Okay. Have I lost? Oh, good. I haven't lost it. Now,
I had a question about the lab.
Garrus, can you wait a second till I get one more thing in? All right.
Okay, yeah.
All right. If you go back to instructor notes, which is where the PowerPoint I just presented was, if you look at the notes, there is something called an exemplar notebook. I kind of did one as I was going along the PowerPoint. I did one here. The only bad thing about it is I got page 2 before page 1. Again, this is how I would do a notebook.
Okay. That's fairly easy.
Okay. Again, this is out of order. This is page 1. The first page is page 2, and this is page 3. Okay. All right. Now, Garrus, your question on today's lab.
Okay, yeah. So in some of the questions on the quiz, it asked if the solid permanently changed color. I was wondering if a precipitate is formed, is that part of the solid being mentioned?
Yes.
Okay.
In other words, when you had zinc mixed with copper sulfate, you form copper. The zinc, what happens is the copper kind of coats the zinc. So it looks like the solid is changing color. The reason he worded it like that is students assume just by looking at it that the solid is changing color. You're not changing color, you're creating a new substance. But yes, Garrus, that's what he means.
Okay, so, okay.
Again, if it gets marked wrong, remind me of this conversation, okay, Garrus?
Okay, thank you.
Anything else that's general?
All right, Professor, you were going to show me the data table in the manual.
I will. Yes, I.
Oh, okay.
Anything about the notebook? Okay, okay. This is the home screen, right?
Yes.
Go to content. Okay. Then once you are in content, you're going to look down to lab manual. Okay.
Yes.
We provide this to you. You don't have to buy anything. So if you click on it, this will eventually populate. You can print this out. Okay, Gaith? Now, if you go down, I need to pull this. Are you seeing the screen?
Yes.
If you go down, it goes down through, gives you purpose, what I call the objective. Goes through a little bit of theory. Then it gives you the procedure. Do not, guys, don't bother listing out the materials. How can I call her? Did she give you a number? Okay. Okay. Okay, by the way, you're just saying the procedures here. They're not all that great. Now, Gaith, your question, your observations. Okay? This is where those occur. Okay?
Got it. Okay.
In the manual, you will always have post-lab questions. These may or may not have anything to do with the results section. In this particular case, it does. You're asked each and every one of these questions. Okay?
Okay, got it. And so last question for the procedure. We have to do the procedure for each change?
No,
or for
Garrus asked me that earlier.
Okay.
I said you could get this time, you could get away with it. Just if you had a solid, you added the liquid to it. If you had two liquids, you added equal volumes of the two liquids.
Got it. Okay.
All right.
Yep. Sounds good. Thank you. Thank you. So that's it pretty much. Yep.
The only thing is I got to go through some of the, for you, anybody who missed the first lap? Corey?
Well, me as well, correct?
Yeah.
I know you did. Corey, you missed it?
Yeah. Is there anything I need to?
Yeah, I
get
need
done?
to go through safety with you guys.
Okay, cool.
Elaine, you good? Elaine, you good?
I believe so.
Literally speaking, what I'm going to do is I'm going through the syllabus and safety right now. If
Okay,
you want to listen to it, you're more than welcome, but that's what I'm doing now.
okay.
Garrus, same thing.
All
Garrus, you
right,
there?
thank you, Professor.
Take
Okay.
care, Elaine. Garrus, that's what I'm
Take
doing now.
care.
So
All right, thank
unless you
you.
have questions, and Garrus, I know you do. So
Okay, yeah. I don't know. I just don't want to ask anything where like you think I'm trying to ask for the answer. So I think I can figure everything out from here.
I think you can too. I have confidence in you. The
Garrus,
thing
did you
is,
get the?
part of the life lesson I'm going to do for you is I'm going to give you confidence in yourself.
Garrus, did you get the?
That's a good one.
The group chat.
Yes.
Yeah. Okay. So yeah, we can help you out there if you need anything.
Basically, it's a funny thing. My wife asked me a question, and the question was, what do you have at 63 that you didn't have when you were 21? And my answer was confidence. Because literally speaking, guys, I mean, even something as silly as asking a girl for a date, you are literally thinking, oh, she's not going to say yes. She's not going to say yes. Whereas if you go up in a confident manner, you're more than likely going to get the date if you go up in a confident manner. So in any case, that's one of the things I've learned.
Okay, hold on. Should I pull my notebook out? Are we doing life lesson, Neil? If you want to give us more
Gaith, I've given you
advice.
more. Gaith, you in particular. I've given you more visuals of life lessons than
I mean, that was a
Okay,
good life lesson. I need more.
So Garrus and Elaine, I'm going to go through the syllabus now in safety.
All right,
So,
Okay, thank you.
all
thank
right, you
you.
take care.
Have a good day.
Bye.
You too. And to this, I got to get out of here.
Have a good one. Oh wait, we're doing.
All right.
Yeah, never mind.
Okay, real quick on the syllabus. It's a lot of things I've already discussed. Are you seeing the screen right now?
Yes.
Okay. To get to the syllabus, course content. Up at the top is syllabus. And basically it is here. This is kind of funky because a lot of the stuff doesn't pertain to you because it's face-to-face. Attendance. This is not a live online class. I'll have to check on it, but I do not believe it is. Because it is not a live online class, it is not required that you attend. I kind of think it's a smart idea for myself. Oh, Jeremiah, I'm sorry. Did you not attend this?
No, I attended. I'm just
Okay.
kind of listening in case I miss anything.
Okay, no problem.
Always good.
You are not required to take this course or to attend the Zoom meetings. You can, I am recording them. You can look at them later. I personally think it's more advantageous to do that because I'm here. You can directly ask questions of me and you can get the answer right away. But that's obviously your choice. There are no makeup labs. I don't let anybody submit anything late. The required assignments, you can find them in the lab manual, or you can look down the list of modules. You're going from safety all the way down to Vesper. They're in order. You're going to be required to do 3 separate submissions for each experiment. There is a pre-lab that's due midnight before I present the Zoom meeting. And there is a results and a post-lab that is due 6 days midnight after I present the Zoom material. The pre-lab and the post-lab are mostly fill in the blank, matching, multiple choice, short answer questions. They're automatically graded. So you're not going to get feedback on those. The only way you'll get feedback on those is if you literally email me and ask me a question about it. Why was this answer this answer? The results section. Results section, Corey or Jeremiah, did you take intro at HCC?
No.
No.
Okay. Each one of, this is especially in calculations, each question is going to have a text box below it. Now, each number you put in there needs a description, where it came from. If you're doing a density of a liquid, you need to put volume. I'm sorry, let's do something else. I'm sorry. If you're doing density of a liquid, mass of graduated cylinder, you have a number for that. You have a label for that. The number has to have the correct number that it should have from the measurement reading. The label should correctly define the volume measurement that you made, but you have to also have a description. You also need to tell me what operation it is, and you have to tell me what the conclusion line is. So if I'm doing the mass of a liquid, the way I would write that, mass of liquid plus cylinder, 6.32 milliliters, minus mass of cylinder, 3.32 milliliters, equals 3.00 milliliters mass of liquid. Does that make sense to you? Corey?
Oh, sorry. Yes.
Okay.
I forgot to unmute.
I know it's a pain, but the trouble is when we get into some of these complicated calculations, sometimes you guys throw numbers at me. I have no idea where they came from. So as a consequence, I get totally lost. So that's why I need the description. You're going to be graded, generally speaking, significant figures and measurement readings. I will mark 30% of the question value wrong if you don't give me those numbers correctly. I will mark 30 to 50% wrong based upon a bad calculation. If you don't put in the description, I got to really make that hurt. So if you don't put in the description, 50% of the point value of that question. And obviously, if you totally futz up the whole thing, you're going to get 100% off. That's basically how I grade the results section. Any questions there? Okay, so pre-lab is 10%, post-lab is 30%, and the results is 60%. You are allowed, you have 14 experiments, you're allowed to drop one pre-lab, one results, and one post-lab. They do not have to be of the same experiment. All right, you have 13 experiments, gives you 1,300 points. You have a lab practical final that is worth 400, and the lab notebook is worth 100. So you have a total of 1,800 points. Straight 90, 80, 70, 60 grading. Understand that I have the ability to lower that percentage. I will not raise it. In other words, I will at times lower the grade for an A to an 87%, but I make the guarantee I will never raise it to a 93%.
Good to hear.
If you need special accommodations, then this is the information for it. My only thought is I have about 100, 150 students right now. If you would please tell me you have a disability before the final, because I'm surely going to forget about it between now and then. And this other stuff is just happy horse shit that you have to put in there. Okay? Questions about the syllabus? All right, now I got to go through the safety stuff. Stop share. And I got to find the safety stuff. General safety, let's try that one. Okay. Anything I say has to be complied with. Any regulations that conflict with what I say, refer back to rule number 1. Any non-adherence, I will kick you out of the lab. I mean, some of this stuff is just crap that you're not going to have to deal with. You will have to deal with this next semester. We're going to be mostly face-to-face next semester. You have to wear goggles from the moment you enter the lab. You need a lab coat. The lab coat will not substitute for proper attire. You have to wear gloves when you're handling chemicals. Shoes got to cover the whole foot. Your clothing. Your pants have to go from your waist down to the top of your shoes. No holes in the pants. Tops must cover your entire body. So if you have the wife beater shirt, do not wear it to chem lab. Don't wear synthetic fabrics. We work with organic chemicals. If you get an organic chemical on a synthetic fabric, it's going to burn a hole in it. Don't wear contact lenses. Don't do any horseplay. Don't mix chemicals unless you're told to. Don't heat chemicals unless you're told to. Do not aim test tubes at other students. The test tubes may be loaded. Each laboratory has a shower. If you do spill something on you, go to the shower, pull the chain, stay there for 20 minutes. If you get something in your eye, and believe it or not, even wearing goggles, you can. I worked as a synthetic chemist. I'm allergic to ethyl acetate, which is basically the thing that makes fingernail polish liquidy. If I'm in the same room with my wife, I get conjunctivitis. It's the vapors that get into the goggles. So even though I'm wearing goggles, I had to go to the emergency room to take care of that. If you do need the eye wash, go hit the plunger, let the water flow freely for about a minute, because you don't want to put standing water in your eyes. Put your face in there, eyes open for 20 minutes. Fire extinguishers are universal. Do not go to an exit that has chemicals. Don't put your head in a hood. Report your allergies. Turn off all equipment, especially Bunsen burners, when they're not in use. Don't return chemicals to their original bottle. Put them in chemical waste. If you spill, break, or set your partner on fire, tell me. Tie back your hair. Wash down and clean everything after you're done. Wash your hands after you're done. Don't taste anything. Don't eat or drink anything in the lab. And that's about it, guys. Any questions about safety? I know it's kind of ridiculous because you're not actually being exposed to chemicals, but I have to kind of say I went through safety.
Yeah, of course.
You have anything more for me? I've been at it for 2.5 hours now.
No, I'll let you take a break.
Yeah, thank you, Professor. Appreciate it.
Hey, I always appreciate your enthusiasm, Gaith. Don't stop. Not necessarily your abilities, but your enthusiasm I appreciate.
Damn. Well, you know what? Something is better than nothing.
Again, guys, you have to understand that Gaith and I developed a special relationship in intro, so
You guys seem like you have fun.
we do. Actually, it was a fun class.
Yeah, it was. It was.
I had a female student that had her 2 kids. One was 5 and one was 3, and they were always just running around during the screening. So it made it a little bit entertaining. So if that's it, Gaith, I will see you tonight.
Yeah, I will do that too.
Wait, what's tonight?
Don't you have me for lecture, Gaith?
No, wait. I need to check my schedule.
Yeah.
Do you have chemistry at 5:30 tonight? Anyway, take care, guys.
I might have a couple questions for
No problem, Corey.
for the lecture, but I think those can wait until then.
No, if you've got them, go ahead. I'm here.
Oh, actually, one thing I was going to ask you. At the very start of the meeting, you were talking about something about extra credit, uploading pictures, something or other. I missed that.
Yeah. The what happens, Corey? People don't look at the video or the instructions on how to upload a picture into my courses.
Oh yeah, I saw the video. Yeah,
All right.
I use Reddit.
You
so
have
I'm
to
familiar with it.
upload the picture, and you have to use the right pixels to get the proper size. Okay.
Yeah.
If you look at your result for the syllabus quiz and you uploaded the picture correctly, then go ahead and submit instructions on how to upload a video. I'll be perfectly honest with you. I am technically challenged. So you guys have a better rapport with one another. You speak the same language. If I have you guys explain it, generally speaking, I get better results that way.
All right.
So if you
Sounds good.
upload the
Yeah.
instructions into the forum, then you'll get 5 points extra credit.
Cool. Sounds good.
You said lecture.
It's escaped me now. Oh, just the. Yeah, never mind. I'll come back to it.
Okay. If you remember by 5:30,
Yeah.
we're going to be in the same classroom. There was
Sure.
a cluster.
I wasn't there last time, but all right.
There was a cluster that happened.
Okay. Yeah. I know. I've had similar situations.
No, this was basically they told me that I'm supposed to only have 14 people in the class, and that if I can't, and that is the limit. So they told me, since you have 23, you're going to have to teach a blended class, which means I'm going to have half the people show up on Monday, half the people show up on Wednesday.
Yeah.
And I'm supposed to teach the other people by Zoom. And you guys didn't sign up for a blended class. You signed up for a face-to-face class. If that happens, if it does turn out to be a blended class, yell, scream at administration, because you're not paying for a blended class. You're paying for a face-to-face class.
Yes, very much so.
Anyway, that's my gripe about what happened.
Yeah.
I had a question about the pre-lab.
Yes, Jeremiah.
So for the lecture pre-lab, so I talked to you last night. Yeah.
You
Or,
talking about the
sorry,
quiz?
pre-course. Yeah.
Oh,
There's a lot of pre's.
all right. Jeremiah, you can listen in, Corey. Basically, you kind of got a bad result, right, Jeremiah?
No, I haven't actually submitted it yet.
Okay, then I'm not
still
going to
kind
say
of going
anything.
through.
I'm not going to say
Um,
anything.
Yeah, I was just curious of like if we should be submitting this or if there was
By 5 o'clock today, yes.
okay. Because I heard something last night when I was talking to you about how there was going to be another one or some type of repost.
Okay, I assumed you had already taken the test. All right.
Gotcha.
Jeremiah, I really want you to try with it because
Yeah.
I want to see what you guys know. That's the reason I'm giving you guys
Gotcha.
this.
Okay.
Plus the fact that I ran into a time because this lecture, I'm missing 2 classes because I have the 2 holidays.
Mhm.
I don't have enough quizzes. I don't have enough quizzes to justify 150 points.
Gotcha.
So what I had to do was I knew I was going to present this participation or this pre-course quiz to you. I said, oh, well, I might as well just add it to the quiz grade and just put 30 points on it. So that's how I came up with the 150 for the quizzes.
Gotcha.
Now, it's I perfectly understand that over that 1 week between spring and summer, you kind of like just let every chemistry thought float out of your head.
I haven't taken a chemistry class since
I haven't
2011,
either.
and I kind of had a breakdown over that quiz. That was rough, but I managed through.
You know, honestly, I didn't think the quiz itself was rough. I really don't.
It was rough if you haven't taken a chemistry class since 2011.
Well, I haven't taken chemistry at all, so I'm kind of going through it, and I mean I'm able to teach myself quite a bit of it, but you know,
Oh
I'm
yeah,
still...
Jeremiah, we talked after class, didn't we?
Mhm. Yep.
Yeah, we talked after class, and I told you there, do the best you can, but don't worry about it, because what's going to happen is after 5 o'clock,
Mhm.
I'm going to reopen the quiz, and I'm going to figure out the last date that I'm going to talk about something that's covered in that quiz. And I'm going to post that as the last date to resubmit the quiz again.
Gotcha.
So basically, and I'm going to give you the higher of the 2 attempts.
Gotcha. Okay.
Does that make sense?
Cool. That makes sense. That's what I
like
heard.
that.
Okay, Corey, you're good with that?
Yep.
Now, I'm not bent on screwing you. I just wanted you guys to give me to be worried about it enough to give me a legitimate attempt. But I'm not looking to screw you.
Well, to be honest, it helped a lot with the, jumping into the deep end first. It got me a quick review and everything. And it got me up to speed. So
well, if nothing else, it just got the neurons sparking.
Exactly.
Okay, guys.
All right.
If it's okay with you, I have to use the restroom.
Go for it.
Absolutely. Go for it.
Yeah.
That's probably too much information, but we'll go there later. Take care.
All right. See you tonight. Bye-bye.